important in coordination chemistry because of the need to have a definite method of describing formulas and writing systematic names. The formulas and names adopted for coordination entities are based on the recommendations of International Union of Pure and Applied Chemistry, that is IUPAC. So, today we will discuss IUPAC nomenclature of complexes, rules for naming the ligands and rules for naming the metal center and oxidation state. Before proceeding further, let us discuss what we have talked in our last lecture. In last lecture, we discussed about coordination sphere, ionization sphere, coordination number and various stereochemistries for various coordination numbers. We must know various rules for IUPAC nomenclature of complexes. You must remember that the name of the complete compound should not start with a capital letter. For example, if you want to name this complex shown here, then the name starting with a small letter is correct and the name starting with a capital letter is incorrect. The full name of the complex ion should be written as one word without any gap. There should be a gap between the cation and anion in case of ionic complexes, and the full name of non-ionic complexes should be written one word without any gap. The cation is named first in both positively and negatively charged coordination entities, and the name of the complex, whether anion, cation or neutral spaces, consists of two parts written together as one word. Ligands are named first and the metal atom is named second. Now, you must consider the rules for naming the ligands. The complete ligand name consists of a Greek prefix denoting the number of ligands followed by the specific name of the ligand. When there are two or more ligands, the ligands are written in alphabetical order, disregarding Greek prefixes. Ligands that act as anions which end in "ide", that is IDE, are replaced with an ending "ido", that is IDO. For example, chloride is named as chlorido. You must note that the 2004 IUPAC draft recommends that anionic ligands will end with ido so that chloro would become chlorido. Now, anions ending with ITE and ATE are replaced with endings ito, ITO and ato, ATO respectively. For example, nitrite will be named as nitrito and nitrate will be named as nitrato. Here you can see various ligands with their names which are used for naming coordination complexes. F- is named as fluorido, Cl- as chlorido, Br- bromido, I- as iodido, O2- is named as oxo, Cn- cyano, Nc- isocyano, OH- as hydroxo, SO4 2- sulfato, S2O3 2- thiosulfato, NO2- is ambidentate ligand, hence it can be named as nitrito N or nitro. ONO can be named as nitrito O or simply nitrito, as SCN- is also ambidentate ligand, hence it can be named as thiocyanato S or thiocyanato. Similarly, NCS- can be named as thiocyanato N or isothiocyanato. Most neutral molecules that are ligands carry their normal names, like En. It is named as ethylene diamine. There are some exceptions also for this rule. These are NH3, which is ammonia, is named as amine. H2O will be named as aqua, CO as carbonyl, and NO as nitrosyl. You must note that amine is spelled with two M's when referring to a ligand. AMINE amine is something else. Polydentate ligands follow the same rules for anions and neutral molecules. The prefixes used to denote the number of ligands are di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, and so forth. Prefixes always go before the ligand name. They are not taken into account when putting ligands in alphabetical order. That is, when we use di or tri before a prefix, we do not consider D or T of di or tri respectively. FeCl, CO whole twice, NH3 whole thrice 2 plus would be called triamine chlorido, dicarbonyl iron 3 ion. You must note that T of tri and D of di are not considered while putting the ligands in alphabetical order. Remember that the ligands are always named first before the metal is. When the name of the ligand also has a number prefix, the number of ligands is denoted with bis for 2, tris for 3, tetrakis for 4, and so forth. The name of the ligand follows in parenthesis. Here is an example. Complex CO En3 Cl3 is named as tris ethylene diamine cobalt 3 chloride. Here you can note that ethylene diamine is a ligand which has a number name in its normal name. Hence, the prefix tris has been used here. When naming the metal center, you must know the formal metal name and the oxidation state. To show the oxidation state, we use Roman numerals inside parenthesis. If the complex ion is a cation, the metal is named same as the element. For example, CO in a complex cation is called cobalt and Pt is called platinum. If the overall coordination complex is an anion, the ending Ate is attached to the metal center. Some metals also change to their Latin names in this situation. For example, copper plus 2 will change into cuprate 2. Here are Some examples where we use the Latin names for the metals. Copper has its Latin name as cuprum, and when we name the anionic complex, copper is named as cuprate. Gold is named as aurate based on its Latin name aurum. As iron has the Latin name ferrum, hence it is named as ferrate. Lead, which has the Latin name plumbum, is named as plumbate when we name it in anionic complex. Silver, having the Latin name argentum, is named as argentate, and tin with Latin name stannum is named as stannate. The rest of the metals simply have ATE added to the end. For example, cobaltate, nickelate, zincate, osmate, cadmate, platinate, mercurate, etc. You must note that ATE tends to replace UM or IUM if present. Finally, when a complex has an overall charge, ion is written after it. Now, we will discuss some examples with determining oxidation states, naming a metal in an anionic complex, and naming coordination compounds. Let us start by identifying the ligands. The ligands here are Cl and H2O. Therefore, we will use the monodentate ligand names chlorido and aqua. Alphabetically, aqua comes before chlorido, so this will be their order in the complex's name. There are 4 aquas and 2 chloridos, so we will add the number prefixes before the names since both are monodentate ligands. We will say tetra aqua dichlorido. Now that the ligands are named, we will name the metal itself. The metal is Cr, which is chromium. Therefore, this coordination complex is called tetra aqua dichlorido chromium 3 ion. In this example, there are 2 chlorido and 2 ethylene diamine ligands. The metal is cobalt. We follow the same steps except that En, that is ethylene diamine, is a polydentate ligand with a number prefix in its name. So, bis is used instead of di. Therefore, this coordination complex is called dichlorido bis ethylene diamine cobalt 3 ion. Here is another example with chromium metal ion. We know that this complex is an anion. There is only one monodentate ligand, hydroxide. There are 4 of them. So, we will use the name tetrahydroxo. The metal is chromium, but since the complex is an anion, we will have to use the ATE ending, yielding chromate. The oxidation state of the metal is +3. So, the name of the complex ion is tetrahydroxo chromate 3 ion. The neutral complex molecule is named similar to that of the complex cation. For example, if we want to name PtNH3 whole 4 PtCl4, we know that NH3 is a neutral ligand and hence the first complex is positively charged. Cl has a -1 charge, making the second complex the anion. Therefore, you will write the complex with ammonia first, followed by the one with chlorine. This coordination compound is called tetraamine platinum 2 tetrachloridoplatinate 2. The point of attachment in case of ambidentate ligands with more than one coordinate atoms is either indicated by using different names for the ligands, example thiocyanato and isothiocyanato, or by placing the symbol of the donor atom attached, the name of the ligand separated by a hyphen. In this example, NCS is the ambidentate ligand in which ligand is attached to the metal atom chromium through nitrogen atom. Hence, this complex can be named as ammonium hexathiocyanato N-chromate 3 or ammonium hexaisothiocyanato chromate 3. If any lattice component such as water or any other solvent of crystallization are present, these follow the name and are preceded by the number of these groups, that is molecules of solvent of crystallization, and it is done in Arabic numerals. For example, you can see here H2O4 SO4 H2O. So, this complex will be named as tetra aqua copper 2 sulfate 1 water, and this complex will be named as tetra aqua dichlorido chromium 3 chloride 2 water. Now, we have to discuss the naming of bridging groups. If a complex contains two or more central metal atoms or ions, it is termed as polynuclear complex. In certain polynuclear complexes, ligands may link to two metal atoms or ions. Such ligands which link the two metal atoms or ions in polynuclear complexes are termed as bridge ligands. These bridge ligands are separated from the rest of the complex by hyphens and denoted by the prefix mu. If there are two or more bridging groups of the same kind, this is indicated by dimu, trimu and so on. For example, in this complex NH2 is a bridging ligand. Hence, the name of the complex will be mu amido bis pentaamine cobalt 3 nitrate. In this example, OH, that is hydroxo, is a bridging ligand. Hence, the name of the complex will be mu hydroxo bis pentaamine cobalt 3 chloride. Now, we will name some complexes by the rules we have studied. Here, there are 4 ligands and these are neutral ligands, and name of the ligand is carbonyl. Hence, the name of the complex will be tetracarbonyl nickel and the oxidation state of nickel is 0. Therefore, 0 will be placed in the brackets after the name. For this complex, there are two types of ligands. One is H2O and the other is OH. As H2O is named as aqua, it comes first alphabetically. Therefore, the name of the complex will be sodium diaqua tetrahydroxo cobaltate 2. In this complex, there are two types of ligands. One is amine and other is nitro. Hence, the name of the complex will be tetraamine dinitro platinum 2 nitrate. This complex will be named as hexachlorido cobaltate 3 ion. There is another complex in which anion and cation both are complex ions. The name of the coordination compound will be tetraamine dichlorido cobalt 2 dioxylato chromate 4. You must remember that the name of the metal in the cation will be used as its usual name and ATE must be added at the end of the metal ion in the anion. Here there are two types of ligands, hence the name of the complex will be sodium diaqua tetrahydroxo aluminate 3. In this complex, oxidation number of platinum is 2. Therefore, name of the complex will be sodium tetracyano platinate 2. Here are some other examples for naming of the complexes. Name of this complex will be hexaamine cobalt 3 sulfate. This will be named as ammonium tetrachlorido platinate 2. Here the name of the complex will be tetraaqua dichlorido cobalt 3 chloride. The oxidation number of chromium here is 3. Therefore, name of the complex will be tetraaqua dichlorido chromium 3 chloride, and this complex will be named as hexachlorido platinate 4 ion. The word ion has to be used after the name of the complex if the complex is an ion. Now, you are able to write IUPAC names of all type of complexes. In the end of this lecture, let us revise what we have discussed today. In this lecture, we talked about IUPAC nomenclature of complexes, rules for naming the ligands and rules for naming the metal center and oxidation state. In our next lecture, we will discuss writing formula for the complexes and isomerism